In today's video, we're going to start discussion how your systems of equations are applicable in our word problems. So we're going to see a lot of similarities as we compare the word problems, place them on the graph, look at the equations and tables. All right, let's get started. So for our first example, I'm going to zoom in a little bit. We have Polly planted a magnolia tree in her front yard. When she planted the tree, it was 4 feet tall. So before there was a growth, this tree was 4 feet tall. Starting value, okay? So the starting value, this is year 0 right here. This is your y-intercept, okay? So we had this discussion where we just talked about slope and y-intercept. So with systems, we're seeing lots of similarities. So you have to have the same approach, okay? So then we know at the end of the year, she's measuring the height of the tree, and then she's recording it in her table. So when we look at our table, we need to determine, hopefully we're comfortable with this. This is our x value. This is our y value. How do we know? Well, first column is always your x, even if it's not labeled, okay? And so then we need to determine the rate of change, the rate of growth. I know we have it labeled, but what was the change? So we are investigating, okay, from year 1 or 0 to 1, 2 feet, plus 2, plus 2, plus 2. Every change that we're seeing, I'm going to make it larger, plus 2 feet. 2 feet per year. It's per year because when we look through this, it's plus 1. So at this point, my friends, we already have everything that we should have for our equation. We begin, okay, let me fill this in, and we know that we need to have only 2 numerical values. We begin with 4 feet, and we know that each year the tree grew 2 feet. Boom, we have our equation. Yes, when you have your table, you can use also these points as your points on the coordinate plane. These data points become your coordinate points. 0 and 4, 1 and 6, 2 and 8, 3 and 10, 4 and 12. Boom, that's the recording that she has, okay? All right, so at the same time that Polly planted magnolia tree, she also planted a pear tree. And this is the equation that shows this particular growth. However, we do have a seed that she has planted, not truly a tree, so we do not have any height. Seed is going to be in the ground, so there's not a height per se. How do we graph this? Well, this is a proportional graph, so we're going to begin at the 0, and then we know that I'm going to give myself a little bit more space. This is going to be our b value. We know this is m. That would be 4 over 1. So year 2, 4 units over 1. Year 2, the tree's growing 2 more feet per year. 2 more feet per year. Not 2, my apologies, 4 feet. This is a great, I'm not trying to catch myself in a mistake or do it on purpose, but I did make a mistake and misspoke. The change, my friends, right here, even though we're going through only 2 units, the value of those 2 units is 4 over 1. 4 over 1. So have to be diligent. You saw me make a mistake. It's really easy to do. So where's the systems? Okay, when we compare both of these trees at the same time, okay, at the same time, that's when they become a system. Okay, so let's talk about what we just reviewed, and we kind of already had this discussion, but let's make sure to write it down. It says, what is the unit rate of the magnolia tree? How much is it growing per year? How much is it growing per year? 2 feet per year. How much is pear tree growing per year? How much is it growing per year? How much per year? 4 feet. Which tree grows faster? Well, what is greater? 4 or 2? 4 indeed, yes. That's our pear tree. Okay. And so when this system comes to life is when we take time, and business owners do this a lot. They have this comparative chart. They're comparing different streams of revenue. And all I'm doing, my friends, I'm just copying these two graphs on the same grid. And voila, that's exactly what we've been discussing the last few days. These two linear graphs have intercepted at this location right here. So the value of this coordinate point is 2 and 8. What does this really mean? Yes, we talked about it's one solution. Okay, we know that 2 years and 8 feet, that would be the label. When we try to analyze the meaning of it, this is when both of these trees will be the same height. Because that's what we're tracking. What would be the height as the time goes? So after 2 years, both trees will be 8 foot tall. And then from then on, your pear tree will keep growing faster because it does have a steeper slope. It's growing faster. And this is our magnolia tree. Okay. So the point of intersection is all about common values for both of them when the values are the same. So that's a very important approach. So when we say x and values will be this, x and y values would be the solution to make them the same, equal to each other. Okay, let's take a look at another example, and hopefully it will remind you of some of the approaches. So I'm going to flip to the flip side of your note, and we're going to just break down this first example right here. There are a lot of important information and good information, so this is a great situation. So we have your school is donating to local food pantry. Your homeroom, back to elementary school days, is having a competition to see who will donate the most items. You have donated, let's start breaking this down. You've already donated 14 items, and you are planning on donating 3 each week. 3 each week. Your friend, you're competing, kids are competing in the homeroom. Your friend has already collected 8 items, already has 8, and plans to collect 5 more each week. So you and your friend are not done collecting cans. You are planning on each week you bring in certain quantity. That's the goal. You plan on bringing 3 each week. Your friend is planning on bringing 5. After how many weeks it will take for both of you to collect the same amount? How much would that be? Here's the situation. This is, once again, we are describing 2 people. Okay? Both of these people, you and your friend, are having this similar situation. You already brought cans and you collecting some each week. So your variable, let's talk about this little underlining that I was doing. That is all of the information that's going to be really important to me. Oh, each week. Each week, how many weeks? I don't know how many weeks. That's what I'm going to find out. Weeks. That's how many weeks to have the same number of cans. All right, let's talk about how the system works when it's two of you guys are competing. So just like before, how can you determine how many cans you will bring? Okay, well, let's talk about it. How many did you start with? You started with 14. Okay, started with. How many are you donating each week? Each week, this is your consistent, constant rate of change. 3x. I did not give myself any room for y. Y equals 3x plus 14. This is you. You. All right, your friend. Can you see? Can you already come up with the equation for your friend? Okay, how many is your friend already brought? 8 items. That is the beginning balance. Okay, how many are you bringing each week? Oh, that's an x, 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 x. Oh, you or he is or she is bringing 5 each week. 5x. Oh, I'm making a mess with this note right here. 5x. Okay, so again, what are the commonalities? You have a beginning amount, 14 you started with, 3x, you bring in 3 each week. Your friend started with 8, your friend is bringing 5 each week. All right. So it is a system because you are describing or analyzing these values at the same time. So what is the main question? When will you have the same amount of cans? And that's that solution that we're looking for. We're looking for, let's graph these equations and see how we can track that point of interception that will give us the answer. And so let's graph yours first. You're going to begin at 14 and 3 each week. So week 1, you're going to have 17. I wanted to give us a lot of space right here, so I'm stretching this out. And so then, again, when you look at this, the change here, you went from 14 to 17, so that's 3. And I made the weeks a little bit longer to just kind of space it out. So it's a good looking graph right here. I'm going to do this again. I'm going to extend. So by week 2, you have 20 cans. 3 per week. Week 3, you have what it looks like. This is 22, 24. So you're going to have 23 cans. And week 4, well, we can't quite finish this up, so we're just going to leave it as that. Okay? All right, so let's go ahead and graph the graph of your equation for your friend, 5x plus 8. And so we're going to begin at 8. That's the beginning value. The slope is 5 over 1. So 5 plus 8 is going to be 13 over 1. This is week 1. Okay, let me zoom in on this so you are seeing my work a little bit better. And so doing this again, a rising 5. Oh, close. Seems like I'm getting really, really close. Or did I go too far? Oh, I went too far, guys. 1, 2, 3, 4, and 5 would be right here. All right, so it's the lower little point. I have to do it again. I'm getting real close. I was getting excited. So one more week. 1, 2, 3, 4, and oh, here we are. So it's going to take some time to catch up. And again, it really helps if you use the ruler. But this is your point of intersection, 3 at 23. What does it mean? After 3 weeks, both will have 23 cans. And here you are. This is your systems of equations where 2 situations are being analyzed and compared on the same graph. Point of interception is very, very important because it shows what values make this information very, very similar. And after this, the growth will continue on its own path.